everybody. So, this is William's technique, Annika here. We'll be going over exact ordinary differential equations today. Which is just kind of like basic differential equations. So, essentially the main concept behind exact ordinary differential equations is, here's like an example up top here. Oops, wait, let me change my pen color. Alright, so this up top here is kind of like an example on why we use exact ordinary differential equations. So we have y dx plus x dy equals 0. Now if we look at this closely, we can examine that this y dx plus x dy is equal to the derivative of the function xy. So if we take the derivative of the function xy, we get y dx plus x dy, and that equals 0. So essentially, since both of these equal 0, we can just set them equal to each other. So we have the derivative of xy is equal to y dx plus x dy. So a more general layout for this is that we have some function mxy dx plus nxy dy equals 0. Now this whole thing up here is an exact differential equation because it equals 0. To determine if something is an exact differential, it essentially follows this format here: y dx plus nxy dy. So that is an exact differential, and up here this is an exact differential equation if it equals 0. Now that's one of the ways to determine if something is an exact differential equation. The other way is if we take the partial derivative of m with respect to y, and we take the partial derivative of n with respect to x, and they equal, that means that is an exact differential. So here we have an example where we have x to the third times y to the fourth dx plus x to the fourth times y to the third dy equals 0. We can see that over here, this is m and this is n. So if we take the partial derivative of m with respect to y, it equals 4x to the third times y to the third. And if we take the partial of n with respect to x, then it equals 4x to the third, y to the third. Now notice that these are exactly equal. That is a necessary and sufficient condition for determining if an equation is an exact differential equation. If these don't equal, that means it's a non-exact ordinary differential equation. And well, since you're learning about exact ordinary differential equations, non-exacts don't necessarily apply until later, usually at, mid to the end of the courses of your first course in differential equations, or sometimes you'll go over them in partial differential equations as well. So, anyway, back to exact differential equations. To determine if m of x y dx plus nxy dx is an exact differential, you have two ways to determine it, which is if you look at the format and see that it follows this format over here, mxy dx plus nxy dy, then it's an exact differential. But to make sure, if you take the partial of m with respect to y and the partial of n with respect to x, and you see if they're equal, that means, if they're equal, that means that they're an exact differential equation. Wow, I'm sorry, the video